Hi guys, Miss Griffin. We're looking at Unit 9, Skill 7. So we're going to be modeling with prior knowledge. So our essential question here says, how do we use prior knowledge to complete layered questions? So these are going to be like multi-step questions, sometimes multiple choice, other times short answer. So when we look at this first problem, it says the density of a white oak tree is 752 kilograms per cubic meter. So I'm just going to write down important information. 752 kilograms per cubic meter, so meter cubed. The trunk of the tree has a circumference of 4.5 meters, so C equals 4.5. And if you think about it, here's a tree trunk, and circumference, if you recall, is the outside, essentially the perimeter of the circle. So C equals 4.5. The height of this tree trunk is 8, so height equals 8 meters. What's the approximate number of kilograms of this trunk? So kilograms is a measurement of mass, or weight if you want to think about it that way. And so in order to use the density formula that also has mass in it, remember that we also have to know the volume. So we have the density, we're looking for the mass, and we can find the volume. So first step is to find the volume, but prior to that we have to have the radius. So I need to find out what my radius is. Circumference is a formula that's given on your reference sheet as 2 pi r. So if I know that circumference is 4.5, it's equal to 2 pi times the radius, which is unknown. So we're going to solve for this radius. That means I got to divide by 2. So that's 2.25 equals pi times r. So these 2's canceled. But now again, I have to solve for this radius, so this time I'm going to divide by pi. And when I do that, we get a pretty nasty number. We're just going to leave it the way that it is, 0.716197. So after we found the radius, now we're going to find the volume. And this is a cylinder in terms of the tree trunk, right? So volume equals pi r squared h, right off your reference sheet. So pi times 0.716197 squared times the height of 8. Type this right into your calculator, get a nasty number again, that's okay. Type the pi in as well, so it's 12.89154. So once we know the density and once we know the volume, then we can go back and find our mass. So we're going to plug in what we know. Step 3 is plug into density equals mass over volume. So density is 752, which is equal to the mass, which is unknown, over our known volume of 12.89154. If I put this over 1, then I can just simply cross multiply. So I have mass times 1, which is just mass, equals 752 times 12.89 blah blah blah. And that gives me 9,694.439. And when rounded, that gives us choice 2. Should be the answer you're circling up top. Okay, so not so bad, but there's multi-steps here. We've got to do a couple different things in order to find out the final answer. Flip it over and we're going to see another type of problem like this. So this top one says a water cup is in the shape of a cone. So if you recall water cups maybe at a dentist office or at an eyeglass place, ophthalmologist, you might get a container that has these cone-shaped water cups. It says the height is 4 and the maximum diameter, so the biggest diameter you could have is 3, but I hate diameters. I don't actually hate them, I just don't prefer them because we always talk about radius instead. So cut that in half, 3 divided by 2. And that gives us 1.5. So I'm going to go ahead and label that. But then it says that we want to know the volume of the water when the cup is only filled to half its height. So here's the cup filled with water to half of its height. So now the height here is only 2, and I want to know what the volume is in total. So I also want to think about what the radius would be. I essentially have 2 similar triangles. I have 4 and 1.5. and then a smaller triangle with 2 and some radius. So first step is going to be to find the radius. And then second step will be to find the volume. So to find the radius, I'm noticing that I just divided by 2. So I can do that again here, or I can set up a proportion. It's totally your call, but you just got to find out what that radius is. So for me, I'm just going to divide by 2, so I find out the radius equals 0.75. So now I'm going to use that. We've got a volume of a cone. So when I look at my reference sheet, it's 1/3 pi r squared h. So 1/3 pi, my new radius, times the height, which is 2. Type this all into your calculator, and you'll get your final answer, and then we just have to round appropriately to the nearest tenth. So when I type it in, I get this value, take the tenths place, look at the 7, that tells me I'm rounding to 1.2. Another question that has come up on an exam before is this one. This is a short answer question, and it's layered. It's a question 34, so it's worth 4 points in total. So we're going to read it first, write down any important information. It says that we've got this cylindrical fueling tank, holds gasoline for pumps, and the tank holds a maximum of 200,000 gallons. So the volume is 200,000 gallons. Has a length of 34.5, so that's this piece, 34.5, which really represents the height of this thing. If you think about standing it upright, this is the height of the whole tank. It says that this metal pole is used to measure how much gas is in the tank. To the nearest tenth of a foot, how tall does the pole need to be in order to reach the bottom of the tank and still extend 1 foot outside the tank? So here's this pole that goes all the way to the bottom and then extends 1 additional foot outside. So all the way to the bottom, going across that circle, is the diameter. So really, it's twice the radius plus 1 more is what we're looking for. Okay? So I'm going to look at this, and it says that 1 foot cubed equals 7.45 gallons. And I want to find my answer in feet. So I have to have my radius in feet, and right now my radius is related to gallons. So first step is to convert. So it says 1 foot cubed per 7.48 gallons. So we're taking skills 9.6 and transferring that knowledge right here. So I've got to have feet cubed over gallons. So I don't know the number of feet cubed, but I do know that the volume is 200,000 gallons. So I cross multiply. 7.48 x equals 200,000. 1, 2, 3, 1, 2, 3, good. And I don't need the gallons anymore. So then we divide. And this tells me that the volume in total is 2673.79679. And this is now in feet cubed because we just transferred from gallons into feet cubed. Okay, so that's our first step. Second step is to figure out the length of the radius. Okay, so we're going to use our volume formula, pi r squared h. That's just from a cylinder right off the reference sheet. I know that the volume is now 2673.79679 equals pi. We don't know r squared, but we do know that the height is 34.5, if you recall that from when we marked up our picture. So I'm going to divide by 34.5. And I'm also going to divide by pi at the same time, but I want you to be careful when you do this. You must put this in parentheses, because otherwise your calculator is going to end up multiplying by pi and you will not get the correct answer. So we have 24.66944 equals r squared, because these cancel and the pi's cancel. To undo the squaring, we have to square root both sides. So the radius equals 4.96683. And then remember that our last and final step is to figure out 2 times the radius plus 1 more for the length of the pole. because remember that's the diameter plus 1 foot outside the tank. So we've got 2 times the 4.96683 that we just found, and then plus 1 more. And this gives us the pole's length to be 10.933669 when I type that in the calculator, and rounding to the nearest tenth gives me 10.9. Okay, let's flip it over. We're going to see one more type of question. So in this problem, again, it's question 34, which means that it's a 4-point question on the exam. And it says a candle makes a mold to make candles shown like the one below. And this was actually a really poorly worded problem with a poor picture. If you can imagine this mold, it's got a circular base and it comes to a point at the top. So this is in fact a cone. Okay, they should have said that or made it a little bit more clear in this picture. And they tell you that the circumference, or sorry, I'm reading too far ahead. The height of the candle is 13. And the circumference of the candle is 31.416. So C equals 31.416. And it says use modeling to approximate how much wax must be needed to make the candle. So how much wax to make the candle is talking about the volume. In order to find the volume, we need the formula 1/3 pi r squared, times the height. But I've got the height and I don't have the radius, so I've got to find the radius first. So first step is use our circumference to help us find the radius, because the perimeter of a circle, the circumference, is related to the radius. C equals 2 pi r, again, that's from your reference sheet. If you want to write that reference sheet, then that's maybe going to be helpful to you. All right, so 31.416 equals 2 pi times radius. So again, when I divide by anything with pi, put it in parentheses. Or do it in 2 separate steps. So we have r equals what comes out to be 5.0000, and then there's other things after that, but this is pretty much 5, right? So then second step is to use our volume formula. 1/3 pi, I'm going to just round this to 5 because there's so many zeros, it's not going to make a difference, and then times the height of 13. And when I type that in, the volume is 340.339, and it says rounded to the nearest cubic centimeter, so that's a whole number. Volume equals 340. And again, don't attach units unless they force you to, because as soon as they say the units right here, you're good to go. Okay, if you attach the wrong units, you're going to get the answer wrong. So I have nothing more to say except go practice. Okay, if you've got questions, let us know, but this is a great skill because they ask questions like this all the time. Adios.